Us to Section 3, the TerraCrop IQ Innovation, Bridging Theory and Practice. This is where we get to that localized, brilliant solution developed at Sultan Idris Education University, or UPSI.
Enter TerraCrop IQ. This is an IoT-based monitoring system built specifically as a teaching aid, and the creators chose to focus on a very specific plant, the Japanese cucumber. Why? Well, because it's a high-value crop with a really short maturity period, just 35 to 45 days. Plus, it is incredibly sensitive to its environment. It needs temperatures right between 25 and 32 degrees Celsius, extremely precise soil moisture, and specific light intensity. It is literally the diva of the vegetable world. If you get the environment even slightly wrong, it suffers instantly. So it's the absolute perfect high-stakes candidate to prove just how valuable precise, real-time monitoring can be.
Now, the physical TerraCrop IQ prototype itself looks deceptively simple. It's built into this wooden crate structure, but when you look closer at the actual components, it's amazing. It's packed with specialized environmental sensors. You've got a DHT22 sensor tracking temperature and air humidity, a capacitive sensor measuring soil moisture, and an LDR keeping tabs on light intensity. Together, these act as the digital skin and eyes of the farm. This hardware sits right there in the dirt with the plants, feeling absolutely everything the plant feels, second by second.
Okay, Section 4, the power of real-time data. Let's talk about the digital leap, because this is where the real magic happens. This perfectly illustrates that leap from the physical to the digital. The physical environment we just talked about gets completely transformed into a sleek, real-time digital dashboard using a platform called ThingsBoard. Essentially, the plant is being monitored on digital life support. You get the exact humidity percentage, the soil condition, the temperature, all mapped out on these really clean, easy-to-read charts and tables. For a student, the guesswork is totally eliminated. The raw data is right there, updating live, right in front of them.
And the elegant simplicity of this data flow is exactly what makes it such a powerful educational tool. It breaks down like this. Step 1. Those physical sensors collect the raw data: temp, soil moisture, light. Step 2. An ESP8266X microcontroller, which by the way is a super accessible, low-cost Wi-Fi chip, acts as the brain to process that raw information. And Step 3. It fires that data via Wi-Fi straight into the ThingsBoard cloud for visualization. This simple flow shows students exactly how physical dirt and sunlight become actionable digital information. It completely demystifies the magic of the Internet of Things.
Let's look at Section 5, Impact on TVET Education, focusing on student usability. We know we have a working system, but did it actually make a difference for the students using it? Well, the researchers tested this out on a sample of 60 students in an agricultural mechanization course using the ADDIE instructional design model. They basically asked the students to rate the system out of 5 across 3 different categories, and the usability results were spectacular. System design scored a 4.69, system functionality hit 4.65, but the most important metric, learning application, meaning how well it actually helped them grasp the material, scored the highest at 4.74 with a very tight standard deviation. It proves beyond a shadow of a doubt that this system is incredibly effective as a hands-on teaching aid.
I really want to emphasize this one powerful number, though: 84.3%. That is the exact percentage of respondents who strongly agreed that TerraCrop IQ improved their understanding of IoT in agriculture. Think about that for a second. Over 4/5 of the class didn't just agree, they strongly agreed that working with a real, live data system unlocked their understanding of smart farming in a way that regular textbooks literally never could. All right, finally, Section 6, the future of commercial agriculture. Let's zoom back out for a minute and look at the macro implications of this project. Because what happens when you take this tech out of a single university classroom? The researchers identified massive commercial potential here. First off, TerraCrop IQ can be packaged up and commercialized as a smart IoT learning kit. That means rolling it out not just to other universities, but to TVET institutions and even high schools that offer agricultural science. Imagine teenagers getting hands-on data analytics experience through farming. Beyond that, agricultural agencies and skill training centers can adopt it to upskill current traditional farmers. And maybe most importantly, this is the foundational building block for advanced digital farming. Once those sensors are in place, you can hook them up to automated irrigation systems, meaning the plant literally waters itself the second the soil gets too dry. By empowering students today, we're building the smart, sustainable farming communities of tomorrow.
We've seen how bridging the physical and digital worlds can completely change our understanding of something as simple as a Japanese cucumber plant. It takes farming from a guessing game and turns it into a science of precision. So I want to leave you with this final, provocative thought.
If accessible, low-cost IoT technology can fundamentally change how we grow cucumbers and how we educate our youth, what else in our daily lives and in the future of global food security can real-time data revolutionize? The digital seeds have been planted. It's up to this next generation of students to see what grows. Thanks so much for joining me on this explainer, and keep questioning the world around you.